Hi everyone, this is Natasha here from the Network team. I'm so excited to be doing a new project with you today. We're going to be doing a databases project, but if you've done a relational database project before, this project is going to feel like a new one. Today, this project is about a non-relational database, and it's called Amazon DynamoDB. Now, if you've never heard about non-relational databases before, that's okay. This project is completely beginner friendly. So anyone with any experience level should be able to do this all good. Now, something you should know is this project does expect you to have an understanding of a relational database. And that's because this project is part 4 of our database series, and parts 1 to 3 was all about relational databases, so this project kind of follows on from that, and it does expect you to at least have a definition of relational databases in your mind. So if you don't really know what relational databases are, that's completely okay as well, because really the key thing to know is that relational databases are structured in a way where things are organized into rows and columns, kind of like a spreadsheet. And if you are familiar with creating spreadsheets, you would know that a lot of times spreadsheets, rows and columns, every single cell in that spreadsheet needs to have a value in it. And that's kind of like a relational database. And you'll really quickly learn the differences between a non-relational database and a relational database with this project. It's also going to be super hands-on, so you're going to get to create that non-relational database. So shall we jump straight into the project brief? So welcome to the Network team. Today, you've just joined the Network team as our data engineer, and we're just thrilled to have you on board. As we build the Network community, we're wanting to store all of the Network projects, videos, and community activity in a database. Do you think you can set up DynamoDB to house all of our data and investigate what kind of insights we can query from our database? So in this project, please get ready to create a table with Amazon DynamoDB, upload data into DynamoDB using AWS CloudShell, query data in your DynamoDB console, and then query data with AWS CLI. If you're new to AWS CloudShell, if you're new to AWS CLI, don't worry. Just know that we'll be doing this step by step, so you get to learn about it from scratch, from day 0. And with every project, there's also this architecture diagram for you to really get a sense of what are we here to build today, right? And in this project, we're here to look at some data, on the left-hand side. Boom, it goes into CloudShell, and there's an arrow from CloudShell to DynamoDB, and then an arrow from DynamoDB to all of these tables. Interesting. I wonder what's happening here. So what you're going to notice in this project is there's almost like a flow of data going on here. You're going to download, or you're going to have access to a folder of files. And then you're going to be using AWS CloudShell, which is kind of like a way for you to interact with your AWS services using something called a command line, which we'll look at later. And then you're basically saying, hey, AWS CloudShell, can you please load all of this data that I have, put it into DynamoDB, so put it into the database, and then tell DynamoDB to load up all of my data into these tables here. Okay, so that's essentially what we're about to do today. Again, this is AWS CloudShell. This is kind of like the channel between us and our AWS services today. And we're saying we're going to go through AWS CloudShell to say, hello, AWS CloudShell, can you please load in all of this data that I have? Can you please, and then tell AWS CloudShell to load all of that data into DynamoDB so that they can go into these tables that you set up in DynamoDB. Cool, so I hope that was a good introduction into this project and what we're going to do. So let's roll up our sleeves and get these done in the next hour. So with every project, you get to choose 3 different modes. You get to do no touch, which is real high-level instructions. It expects you to be someone that's already very comfortable with how to use AWS, how to create databases, and then you can move. And then there's also low touch in the middle. So low touch here gives you some guidance. So maybe you've done a DynamoDB project before, and you're just thinking like, I'm still a bit of a beginner, but I want to give myself the challenge. You can pick low touch. High touch is what we're going to be doing today, and it basically expects you to be a complete beginner that has never really done a DynamoDB project before. It could be your very first project, and it's going to show you every single step, every single click, every single thing you should type in. So with that being said, let us get started with today's project by just recapping. Okay, what are we here to do today? It's so easy to read a step-by-step project guide and say, like, okay, yeah, I'm just going to do step 1, step 2. But this question is going to force us to recap and really understand, what are we here to do today? Okay, so let's type in our answer. In today's project, we are here to create a DynamoDB database, i.e. tables, and then use AWS CloudShell to load existing data into the database. All done. Nice. So we are going to need to log into your IAM user to do this project today. So if you don't have an IAM user, we go through how to set one up in a link in the description. But in the meantime, if you don't have an IAM user, please visit that link. Or you can follow the steps on how to create an IAM user from scratch using this guide here. All right, we've written it all out. Now, I've already logged into my IAM user, so I've already created one. I'm already here so that we can get started straight away. But if you are still new to creating IAM users, refer to this guide. You should be all good. And if you get stuck, ask a question in the chat, ask a question in the comments. We'll be there with you shortly. Okay. So now that you've logged into your AWS account as your IAM user, the first thing we're going to do is create our very first DynamoDB table. Now, this is really the foundation. This is where it all starts. So once we have a DynamoDB table, we can learn how to populate it with data, which we're going to do in a second with CloudShell. And then we're going to learn how to query it for insights in the next project. Lovely. Lovely jubbly, let's get started. So in this step, we will set up a DynamoDB table from scratch. As a heads up, all of these questions need to be answered if you'd like to get any documentation for this project. So highly recommend that you answer these questions as you go, or if you prefer for your learning style to answer them in one go at the very end, although it's very important that you take screenshots as you go when we prompt you to. So let's do that. All right, so let's start by getting into DynamoDB in the AWS console. So let us click on DynamoDB right over here. And if you don't have DynamoDB in the front page, you can find DynamoDB by using the search bar like this, clicking search, and then type in DynamoDB, and it should be the first result as well. So you can just click here, and then you end up on the same page. So welcome to the DynamoDB console. This is a place where you can set up a table, set up a DynamoDB database, and then also create tables, all that stuff. Anything related to DynamoDB should live here. And then in this case, we're going to create a table. So what is DynamoDB and what is a table? So DynamoDB is a non-relational database service. Non-relational databases, they use structures that aren't rows and columns to organize their data. So there are all different kinds of non-relational databases. DynamoDB is just one of the many, but there are a lot of different types out there. So an example is, if you really want to have a look, I think, can you type non-relational here and then you instantly see non-relational databases? Yeah, you do. See, search up non-relational and look at this. So Keyspaces is another non-relational database. RDS is a relational database, but DocumentDB, another non-relational database. Very cool. Let's see. I think there's also Neptune, for example, which is another kind of non-relational database. So there's so many different kinds, and DynamoDB is described as a NoSQL database or a key value database. So key value is really the keyword that sets apart DynamoDB from a lot of the other non-relational databases out there. And you're going to see what key value means. But for now, just know key value is the way that DynamoDB databases structure their data or organize their data. And it's really the defining characteristic of DynamoDB, in my opinion. So a NoSQL database means you can't use SQL to query it, and you would know that SQL and using SQL to query it, when do you use that? Do you remember? You would use SQL to query relational databases, but again, DynamoDB is non-relational. So in this case, you can't use SQL to query this database, but key value, which is the specific way that DynamoDB stores the data, is known to be very flexible and very efficient. Okay, so this is a very, very key paragraph that gives you a hint for the rest of this project. If you don't understand it yet, you'll definitely understand it by the end of this project. So what is DynamoDB tables? So DynamoDB tables is kind of like separate sections or separate containers of data. And in this case, all data in DynamoDB is organized into tables, and then you would use different tables to store different data. So, for example, in a relational database, you can have multiple tables or multiple spreadsheets, but then you can think of DynamoDB as kind of like the big folder of all the little tables that you have, and each table will just contain different data inside. Here's a random example. If I were to store tables on things to do with Nextwork, I would have one table that's like, here are all of the Nextwork users. I have one table that's like, here are all of the Nextwork projects. I have one table, here are all of the posts and comments about Nextwork on LinkedIn. It's kind of like, it just stores different data inside. And then all of these tables use items and attributes to organize their data. And then we're going to see items and attributes in a second. So as we mentioned, DynamoDB doesn't use rows and columns to organize their data, but also DynamoDB is in tables. So how is that possible? It might sound impossible to have a table that doesn't use rows and columns, but that actually is exactly what DynamoDB is like. You'll see this in action soon when we talk about the items and attributes here, but in short, you know how when we think about a table, we think about a set of rows and a set of columns, and then it's like every single row has the same number of columns. But what if your table, every single row, had a different number of columns? This extremely flexible. The first row only has 2 columns, the second row has 5 columns, and each cell or each column inside each row can have a different column heading. So you can see how it's just so flexible. And that's your big TLDR on how DynamoDB tables are extremely different to a relational database. So we're going to start by creating our table. And when we create our table, we're going to give it a name. This time it's called Nextwork Students. And then for the partition key, we're going to use student name. Okay, now partition key over here is kind of like the filter that DynamoDB will use to split up and find data later on. And partition key values don't have to be unique. For example, if my partition key is like color, I can now and later on, after I create this database, create this table, I can use color as the way to split up my data. I can say, oh, split my Nextwork students table based on color, and then DynamoDB will be like, all right, all of the red students are in one partition, all of the green students are in one partition, all of the, I would say all of the bright orange is in another column, is in another partition. So it's just a way for DynamoDB to use to filter all of the data and split them up into almost smaller groups, smaller partitions. And the reason why partition keys are so important is because without a partition key, DynamoDB would not be able to find a piece of data, would not be able to find that piece of data. So imagine if you tell DynamoDB, oh, the partition key or the way you're going to split up data is by color, and there's one cell that doesn't have a color value, then DynamoDB will never be able to find that item because it's split up everything by color, and it can't grab that item because there's no color attribute to grab onto. So that's why every single value needs to have a partition key value. Every single item needs to have a partition key value. And it's why the partition key we're setting up right now is actually going to be important for later on. And again, we're going to go into this in a second. But this is like a bit of an in-depth explanation of partition keys for anyone that's curious. Cool. So we've entered Nextwork students, we've entered the student name as our partition key, and now under table settings, we're going to customize our settings. And we're customizing it so that we can use settings that absolutely fall into the free tier with AWS so we don't get charged for this project. Now, once we're here, try expand the capacity calculator. And you're going to see this calculator is a way to calculate costs associated with this database. And it gives you something like, oh, item read per second, item write per second. There's even a cost estimate at the bottom. Please know that this project is going to be completely free. Even if you're seeing a cost estimate, it's going to be free for you because you're going to be deleting all of the resources by the end of this project. Just make sure you delete your resources, and this project won't charge you anything. So, as you can see, item read per second, item write per second, this helps to determine the final cost of a DynamoDB database or a DynamoDB table. This is not required knowledge, but it's honestly such a good to know to understand what is item read per second and what is item write per second. Item read per second in DynamoDB means your application can retrieve one item of data from your database every single second. Okay, so if we were to change this number, okay, if I were to say 2, this means DynamoDB can read 2 items in your database every single second. This is important because it determines how fast web apps can get access to your data, for example. Because if you were to say you can only read 2 items a second, you'll probably have to, they'll probably have to wait quite a bit if it's like a huge data set and a lot of data needs to be extracted out from it. Now, item write per second is something that's very similar. So just like item reads, 1 item write per second means your app can save or update, delete, all of that, 1 item a second. That's all. So we won't change anything in the capacity calculator for now, but this is just kind of something for you to understand how charging or DynamoDB pricing works. Changing these values, changing how many items your DynamoDB database can read or write a second is going to have a big impact on how much it's going to end up costing you if you were to use it for a bigger project. Now under read or write capacity settings, let's make sure costs are as low as possible, right? So for auto scaling, under read capacity, we're going to turn it off. On the write capacity, we're going to turn it off as well. Okay, and notice how the moment you turn off auto scaling, provision capacity units becomes a field that you can just enter. So auto scaling is something that if you want to understand what auto scaling does, you can click on info to read like a pretty in-depth explanation. But in short, auto scaling is kind of like an extra tool or an extra helper that AWS will give you that automatically adjusts your database's performance based on real-time demand. So if DynamoDB detects that it's not reading a lot, it's not writing a lot, it's going to lower the performance requirements. It's going to lower one of its settings, and doing that helps you save cost. But the reason why we're not going to keep autoscaling on is because the other way is true as well. So if DynamoDB detects that, oh, it is reading more or it is writing more data than what you've expected, what you've input, it's going to automatically adjust up. And that can easily end up charging your AWS account. So again, we're just going to turn this off so that your project is going to stay in the free tier. So we've turned off autoscaling, okay? Off and off. Next is to understand what is provision capacity units, right? So we're gonna take a screenshot first of our read-write capacity settings page, and then we are going to talk a little bit about the differences between what is going on here, provision capacity units. So we're gonna take a screenshot. Just like that, and then we're gonna upload here. Done, we're gonna click done. Very nice. So here, we're gonna change provision capacity units to just one. 1 and 1. Nice. So changing this back to 1 is something that helps you again in terms of pricing with DynamoDB. To better understand capacity units, let's have a look at the capacity calculator one more time. Do you see how there's capacity units mentioned here too? Read capacity units and write capacity units. So in the calculator, just try changing the number of item reads per second to 2. Aha! It still says 1 read capacity units. Okay, now let's try changing it to 3. Oh, do you see how the read capacity units number went up to 2? So what's happening here? Let us have a look at the definition of read capacity units. So read capacity units is kind of like a way to measure how many engines DynamoDB is using to operate all of the read operations. 1 read capacity unit, so if we were to go back to 1, or if we were to go back to 2, so 1 read capacity unit means DynamoDB is just using a single engine to run like the read operations. This lets DynamoDB perform a max of 2 reads per second. So what this means is 1 read capacity units can go up to a maximum of performing at 2 reads per second. So if you decide you actually want DynamoDB to run a bit faster, like, hey, can you read things faster? Can you actually read 3 items a second? DynamoDB is going to say, yeah, of course I can read more per second. It's just going to cost you more because I'm going to add another engine to me. I'm going to add another read capacity unit, which is going to allow me to move at a faster rate. So with that, notice how estimated cost is, US 78 cents a month. But if I were to change the item read per second back into 2, okay, and the read capacity units go back to 1, the price is lower. Awesome. Now try increasing the item write per second. So let's go from 1 to 2. Oh, look at that. The write capacity unit instantly goes up by 1, and our estimated cost is even higher now. All right, so what's really happening here is we're seeing that 1 capacity unit for writing can only equal 1 item write per second. So do you see how the equation is slightly different? Here, we can still read up to 2 items a second and still stay in just 1 read engine. But when it comes to writing, when it comes to editing, 1 item write per second is going to take up a whole capacity unit for writing. So that is just like another tidbit in terms of how DynamoDB charges, like how pricing works. But this is going to be a little bit important when it comes to understanding how to make the most out of DynamoDB by being very efficient with the reads and writes. So I just want to emphasize to you now that you won't be charged for this project as long as you delete all of the resources once you're done, because the free tier for DynamoDB gives you 25 gigs of storage, plus you get, you see these read capacity units and write capacity units, you get 25 of each for free. And in this case, we're only going to be using 1 read capacity unit and 1 write capacity unit, so we're going to be safe. Cool. So once that's done, let's recap. What have we just learned about read and write capacity units? Read capacity units and write capacity units are units that measure my DynamoDB tables performance. DynamoDB pricing is based on the RCUs and WCUs. So the more RCU, WCU consumed, the more expensive the operation, the more expensive the project. What is covered under DynamoDB's free tier? Good question now. Amazon DynamoDB's free tier covers, I turn off auto scaling because, and Amazon DynamoDB's free tier covers 25 RCUs and WCUs monthly. I turned off auto scaling because this can result in higher charges if DynamoDB automatically scales up my operations, which charges more RCUs and WCUs. Awesome. So once that's explained, you're all done. Great. So we're going to create the table now. You're going to see again, there is a bit of an estimated cost, but we won't be charged because we're running under the free tier. And then we can go straight into pressing create table. Very nice. So the table is getting created now over here. And once the table is created, you can just click into the name Network Students, and then you can take a look around before you move on to the next step. Just get comfortable with the screen because you're going to be seeing kind of a new service, and it's going to look a little new. You know, look at this kind of interface. It's quite like, whoa, to look at the first time. But here's a list of all the tables in DynamoDB. Okay, and there's this pop-up that you can close. There's some information about your DynamoDB table. There's even a summary of all the items in your DynamoDB table. Capacity metrics, oh, there's so much stuff. But in this case, what we're going to do now is we're going to select Explore Table Items on this top right-hand corner. And now we're kind of like clicking into the table itself. So we're actually just reading the items inside that table. So now that we're looking at all the items in our table, we have 0 to start with. That's right. So we just created this table, so of course it's only going to have 0 items inside, but that's okay. Let us create the first one. So we're going to click on Create Item, and ta-da! From the DynamoDB console, you can enter data manually straight away. You can literally just start entering data into your database table. It's such a handy feature because DynamoDB is actually very unique for letting you do this. In fact, most database services don't let you just enter data manually from like the AWS console. You know, if you've done the previous projects, you would notice that you could never like just enter data directly from the AWS console, but with DynamoDB you can. So this feature really highlights DynamoDB status as a fully managed AWS service so that you can concentrate more on, building your application, doing the other things, and AWS is here to just really make having that database as easy as possible. Cool. So let us enter our very first item into this database table. So here, for our very first student name, let us enter Nico. Okay, so once we do that, we can actually even click on Add New Attribute. Whoa. And select number. Whoa. Now we can even add an attribute. So it's kind of like adding a new header in your table. And in this additional header, we're going to now also track projects complete in this table. We're going to say Nico completed 4 projects. All right, and we're going to create the item. So what is an attribute? An attribute is basically a piece of data about an item. Okay, and in this case, we have an item, which is the student called Nico, and then an attribute is kind of like a piece of data about the student. Oh, we know that the student name is Nico. Now another attribute is the number of projects complete, and that's 4. So projects complete is the attribute itself, and then the value, so the number we're going to give for this specific item is 4 projects complete. Each item in DynamoDB can have multiple attributes, okay? But unlike relational databases where every single row in the table will have the same number of columns, again, please think of DynamoDB items as like every single row having their own number of columns. Okay, just think about that. The more you think about that, the better you can understand how DynamoDB data structures work. All right, so with that done, let us select Create Item. Get that finished. Look at you go. Very nice. So what is an attribute again? Can you remember? Can you explain what is an attribute? An attribute is a piece of data about an item in the table, in the DynamoDB table. For example, if an item was a specific student, attributes could be student name, projects complete. What are some other attributes you can think of? What are some other attributes you could save about the student? Let's use a specific name here. So if an item was a specific Nextwork student, attributes could be student name, project complete, email, sign up date, so many. The number of attributes for each item is flexible. Done. Okay, so once you've created it, notice that there's going to be this green success banner when you scroll down, and it says completed. Read capacity units consumed, 0.5. What does that mean? Does it mean out of the 25 free capacity units we get with AWS, we've already just used 0.5, so we only have 24.5 left? No, actually, that's not really how it works. So again, think about read capacity units as the number of engines, right? And in this case, this doesn't mean you've just used half an engine and you only have 24.5 engines left. Your AWS free tier will go over as when the speed of what your database or what your DynamoDB table requires goes over needing 25 engines at the same time. All right, so you can consistently keep putting through data as long as this line will never say read capacity units 25. Think about the number of RCUs or the number of read capacity units like you're driving a car and the RCU is your speedometer. It's kind of like this is the speed you're going at, the speedometer. And it's like, vroom, okay, you're going at the specific speed. Right now your speed is 0.5, right? You can consume 0.5 read capacity units at once. But let's say eventually your database table like speeds up a lot and all of a sudden, you know, your speed goes over the limit and you go over needing 25 read capacity units. And when that happens, that's when the AWS free tier limit is, you've gone over the AWS free tier limit and you're now going to start getting charged. So you're basically safe as long as you're not asking your table to speed up and read a lot of things at once. Okay, you'll be okay. So check your work now. Do you see a table called Nextwork Students? Okay, we have a table called Nextwork Students. And then is there a student called Nico? Yes, there is. So congratulations, you've already set up a table and you've even added an item into that table. Now, just to be very clear, how is DynamoDB a non-relational database? Isn't this rows and columns that I'm looking at? You might be thinking it's a bit contradictory to say, oh yeah, DynamoDB tables, they're not like organized in rows and columns, but then this looks like rows and columns, doesn't it? So instead of looking at this like rows and columns, please look at this as a table where every row is its own list of attributes. So in this case, we have one row, and this row has two attributes. This row has student name as an attribute and projects complete as an attribute. You're going to see other items that could have a whole row of like 4 attributes, 5 attributes, or 1 attribute, no attribute at all. Maybe that last one might not be true. Maybe you do need at least 1 attribute. But as you can see, you should think about this as every single table has a different number of attributes, or it can be completely flexible, to whatever the table is storing. Now, the reason why I said, oh, maybe it's not true that you can have 0 attributes is because remember how we set the partition key? Every single item must have a partition key value. Well, in this case, student name is our partition key, right? We entered that in the earlier in the step. So in this case, every single row must have a student name to it. So let's take a screenshot of that next work students table. Nice, nice, nice. And let's save that screenshot in here. It's looking good. So how is data organized in a DynamoDB table? DynamoDB tables organize data using, do not say rows and columns, using items and attributes. Every single item is made, every single item is recorded with a set of attributes. Items can have any number of attributes, minimum 1 for the partition key. Done. Satisfying, eh? So I love it when it turns green. All right, we're now ready for step 3, which is to create DynamoDB tables. Again, we're going to be creating tables, but this time we're going to create 4 in an even faster speed. How might we be able to do that? Now, we're going to do that by using a tool called AWS CloudShell. Why would you want to do that? Well, you can probably imagine that creating tables and items one by one, imagine if I had 1,000 students, or if I had like 5 tables I wanted to create, and I was entering all of these items one by one, create item, create item, create item, create item. It probably isn't the fastest way to do things. So let's do things in a faster way by using CloudShell to help us out. In this step, you're going to interact with DynamoDB using a new way. We're going to use AWS CloudShell, and then we're going to run commands or instructions to CloudShell to create these tables in lightning fast speed. All right? So in this step, we are creating new tables in lightning fast speed by using AWS CloudShell and running commands through CloudShell. Done. Alrighty, so at the top of the AWS Management Console, this is how you can find CloudShell. Do you see how there's this icon right next to the sidebar? Click on that. Alright, boom, CloudShell pops up from the bottom of your screen. Alright, I have a terminal getting prepared now, and my terminal is ready. So if you don't see this first line, ls, don't worry, this is actually something unique with my CloudShell terminal because it's something I put through before this project, all right? So you really only need to be seeing this bottom line here. So that says CloudShell user, ready. So CloudShell is a shell in your AWS Management Console, which means it's a space for you to run code. Okay, this is a space where you can type code directly, press enter, and then the code's gonna run. The awesome thing about the AWS CloudShell is that it has this tool called AWS CLI pre-installed in there. So AWS CLI is a software that lets you create, delete update AWS resources using written commands instead of clicks with the console. So imagine if I can just type in here, like DynamoDB, add new item, and then I press enter, and then I am like writing out, the item details and all that. That is like something that you can do with the CLI. You can almost do things that you would usually do using clicks, turn that into a line of code using AWS CLI, and then when you run that code, that action just gets done, in AWS for you. So it's just a very, very great way to do things very, very efficiently in your AWS environment. Usually AWS CLI, like I said, is a software, so it needs to be downloaded. But in our case, CloudShell already has CLI installed in here. It's already been downloaded for you, which is why CloudShell is quite useful. Yeah, and an extra bit for experts, if you're keen to know, as you advance in your cloud engineering career, AWS CLI becomes the go-to tool over using the console. Clicking around in the console is great for showing demos, great for learning, great for really understanding what a service is doing for the first time. But most of the time, as you become more mature as an engineer, you aren't really touching the console anymore. You're going to be doing things using CLI a lot more instead. So this is why this step is really practical. It gives you a little taster into using a tool that engineers are definitely using more than the AWS Management Console, when it comes to the real world, when it comes to engineers currently working in engineering teams. So now that your environment is ready here, AWS CloudShell is an environment that lets us run code to interact with our AWS and AWS resources, services, using AWS CloudShell is handy because AWS CLI is already installed. So we can run commands right away. Wow, what is AWS CLI then? Well, AWS CLI is a software that lets you interact with resources using commands instead of clicks in the console. This is a very practical software that is preferred over using the AWS Management Console in day-to-day engineering operations in the real world. In day-to-day engineering ops in the real world. And let's just also make sure that I haven't repeated ourselves too much. I think it's okay. I think this is all good, but if you'd like to be more concise, I know my explanations are usually a little bit on the wordier side. You're more than welcome to. Let us click done as they're all finished, and let us run our first command. Now, this is a pretty hefty command to be running for the first one. The next commands you run will actually be shorter than this one, but you absolutely need to run this one first because this command helps us create new tables. Look at that. Look at how this command looks. There's a line that says AWS DynamoDB create table. Isn't that so clear? You know right away what this is going to do, isn't it? You're going to be in AWS, you're going to access DynamoDB service, and then the action is to create a table. So this is a very, very common kind of syntax or a common way to organize instructions that you put through into CloudShell or by using AWS CLI. First AWS, and then the service name, and then the action. So in this case, we are creating tables many times because you have DynamoDB create table here, and another create table here, another create table here, another one here, right? So we're creating 4 tables in total. And each of these tables have their own table name, okay? So this table has a name called content catalog, Okay, and then a different table name here, and a different table name here. So it looks like a very intimidating piece of code if you're new to AWS CLI, but just know that this command helps you create 4 tables. End of story. So copy that code, and then paste that in here, okay? And look at that go. It's already running. Wow, look at that. That was very, very fast, wasn't it? So the moment you see that you've returned to this cursor state, this little rectangle here, it means that your commands have finished running, and we can see the results right away. Yeah, so off we go. Let's have a look at what your what CloudShell has just created for you. Are you ready? All we have to do is refresh this page, okay? Or if you'd like, you can go from here and click on tables, and then press that refresh button here. Look at that. Just like that, we have 4 new tables. Like we mentioned, there's 4 more, right? And the first one, it says content catalog. Aha, content catalog. It's created. We've told CloudShell, create a table called form. Ah, a table called form gets created. How practical is that? So can you see how this could be a lot more efficient than creating a table and doing it manually? So if you're wondering what are all of these other numbers in here, these numbers in here are basically telling us other attributes, like there's an attribute here that's going to be called ID. There's going to be an attribute, an ID is a number, right? So that's what this line is saying. And then for form, there's going to be an attribute called name, and that name is a string. It's a piece of text. You can even double check this, right? So it says the table is called form. So let's click into form. And then it says here, there's going to be an attribute called name, and it's going to be a piece of text. So scroll down. Oh, explore the table items when you scroll. Aha, there's no items yet, so we can't double check those attributes. But once you load in data, you can see. That's all good. Cool. By the way, when you paste your data, if you see this little panel that says, oh, are you sure you want to paste multiple lines? Just click paste. But also, if you liked to stop seeing this pop up, because it's going to come up again and again and again and again, if you want to prevent yourself from seeing this pop up all the time, you can also untick that little checkbox here, this little checkbox, so it doesn't come up. All right, so we're going to take a screenshot of the command's results. Okay, this is a part of it. Your screenshot doesn't have to be too big. It doesn't have to contain all of the results. So something like this works. All right, and let's load that in. Cool. Gonna let it take time to load. All right, and then what was the command you ran? Can you have a think about how you're gonna respond to this before we respond together? Cool. Here, we're gonna write down, I ran a CLI command in AWS CloudShell that created, I ran a CLI command in AWS CloudShell that created 4 new DynamoDB tables. That was insane. What else do we want to say? The command is called AWS DynamoDB create table. And we can even be clearer, the AWS CLI command is called AWS DynamoDB create table. And I could even define the table name and its attributes all within the command. Nice. So let's confirm that these tables were actually created. Oh, sorry guys, I know I jumped ahead and I already confirmed it together in the console, but let's just pretend we haven't seen that yet. that's that's a bit naughty of me, but let us copy this code as another way to double check that we've created the tables. So this is the CLI way for you to confirm that the tables were created. Let us copy the code and let us paste that in here. Interesting commands, isn't it? This command says AWS DynamoDB wait. Wait. Isn't that an interesting command? Okay. Wait, table exists. Table name, content catalog, table name form, table name post, table name comment. So what's happening here is we have a command that says wait and do not move on until the table has been created. Wait commands are really helpful because if you have a command later on that relies on something that you've created being done, so in this case, we needed to make sure that this table has been created for us to move on to the next step, you would use wait commands to just confirm that the resource is ready to go before you run any of the other commands. Because if you were to run any of the other commands first, you'll likely just run into errors. And this is a great way to just confirm that the resources are ready to go before you run those other commands. Now, can you guess what will happen if you run a wait command before you create the actual resource? In this case, imagine if we said AWS DynamoDB wait. Table exists, table name is computer. We haven't even created a table called computer. So what's going to happen to this command? Right? You know what? Let's even type it in so we can see it as a little extra. Computer. What's going to happen? Do you think you can make a guess? As you can see, DynamoDB is being told to wait. We told CloudShell, we told DynamoDB to just wait until this resource is done creating. So it's just waiting. It's just gonna keep waiting for you. Eventually, it will fail. It will say, "Hey, like waited too long, and this resource definitely doesn't exist." But in our case, you can also press Control-C on your keyboard. Control-C. And that helps you with just exiting this command. So you're not stuck waiting and waiting and waiting yourself before you can run your next command. So now that we have confirmed though that these 4 tables were definitely created because the wait command finished, it's done waiting, it could move on to the next one. We have confirmation that the tables are created using AWS CLI. And then we could even see it over here, right? The tables. So you might also be wondering just now, like I mentioned, when you were looking for content catalog, when we were looking at form, there weren't any items at all. Is that okay? That's totally normal. Initially, DynamoDB tables are created empty, just like how when we created Network Students, there were no items in there. There wasn't a Nico item at the start, so don't panic. We're going to be learning how to load a lot of data into each of these tables using CloudShell for the next step. All right, so in the next step, load data into your tables. Let's get ready to load some data and then view and update that loaded data. This is such a good step for you to really understand how DynamoDB organizes and stores its data. So it's a really, really good step. I would say out of all the steps in this project, this is really the one to be paying attention and making sure you're really understanding all of it. So let us get ready. In this step, we are going to load data into the DynamoDB tables using AWS CloudShell, AWS CLI, and afterwards, we will also update the DynamoDB tables, i.e. add new attributes, edit attribute values, etc. All right, so we're going to head back into the CloudShell terminal, and then we're going to download and unzip a file that contains data. Do you remember how when we first looked at this diagram, we said we're going to have some data, and then we're going to tell CloudShell, hey, can you please load this data into DynamoDB so you can organize them into the different tables. All right, we've done the creating of these tables. We now know how to use AWS CloudShell. You know, it looks like this. We now know how to use AWS CloudShell to interact with DynamoDB, but in this step, we're going to learn how to do this flow. How can you go from a file to CloudShell all the way into getting it loaded into here? So this is how we're going to upload that file. We're going to use this command that basically downloads a file that has been stored in the cloud. Okay, you're going to download this using this link. And then you're going to unzip the file. And then you're going to go into the folder that comes out when you unzip the file. So what this is going to look like is we're going to run this command through CloudShell. So instead of downloading this folder into your local computer, into this computer in front of you, you are actually downloading this folder, this zip file, into the CloudShell environment. So let's run this command first, all right? And you can see that it unzipped the file even, and it could even see all of the items that were inside the unzipped file. So what's going on here is we have even gone into the folder that's called next for example data, and then we're inside that folder now. Okay, we're inside that folder now. So if you're thinking, whoa, how did that happen? First of all, you can totally unzip files and store files inside this CloudShell environment because CloudShell can also handle 1 gig of storage. And with that 1 gig of storage, you could use it to save files and then use those files to load data into DynamoDB, what we're doing now. Or if you were to load a bunch of scripts, you know, scripts are basically lots of lines of code that your computer can run so that it can automate tasks for you. So you don't need to type in lines one by one. You can just say, hey, CloudShell, run this script. And then now CloudShell is going to run like 100 commands for you, or 2,000 commands. How many? No, just the number of commands is inside that scripts file. And that's the reason why having storage inside CloudShell is so handy. But okay, if you're still thinking, oh, that was a bit confusing, like I don't feel really comfortable understanding what these commands were doing, you can honestly, this is just an extra for yourself, like if you want to, you can honestly copy this file name, right? And then you can go to a new tab, and then open a new tab, just run that URL, and that URL is going to download the exact file into your local computer. And this lets you view that file in your local computer. So see that? I could even see that file in my local computer now. Here we are. Awesome. Look at that. So technically what we've just done here is we've also downloaded that file into our local computer. We could even expand it. We even unzipped it, right? And then we can even go into that folder and then look at all of this. These are the files that we've basically just unzipped into our CloudShell environment. Good to see. Okay, so that was just a little extra if you're wondering what was going on here when you ran these commands. Cool. So now that that's done, what we can do now is we can run ls. Okay, ls. And ls tells us, okay, in this folder you have 4 files: comment.json, contentcatalog.json, forum.json, there's post.json, just like this, right? Just exactly like this. Content catalog, comment, forum, post.json. So really what you're doing, in these commands is you're really exactly like what we mentioned before, you're like replacing clicks. by using these commands instead. Okay, so you have opened this folder inside your CloudShell environment. And now you might be thinking, well, one thing that we can't do is so far, we can't double click on a file, right? Using this terminal, we can't really double click on content catalog.json and open the file. But, with such a simple interface, I can click on content catalog.json and it's going to open it for me. It's going to look like this. When I open it, it's so quick and easy for us to just use clicks. Well, it turns out you can actually still open files inside this terminal. So you can just go cat forum.json. Look at that, it opened the file for you. So this is what's inside, and exactly matches, what we were to see if we were to just try to open that locally. So that's very handy. Forum.json has all of these lines inside. We can see it now. Helpful, eh? So that's the reason why CloudShell is just such a cool way to replace clicks. You can just type in whatever command you want, and you can get the result right in front of you. So now that we can see what's inside forum.json, what's inside anyway? Let's break it down. Forum.json contains data that's been formatted specifically for loading into a DynamoDB table. Forum over here tells you that this data in here is for the forum table, right? This data in this file is for the forum table over here. And then put request is basically telling DynamoDB that this data needs to be added to the table. Add this item, please. Add this item to your table. And then here, within your item, you have your attributes and your attribute values. So this item has a name called I have a question. This item has an attribute called category, and the category for this item is next with community, so on and so forth. Okay, so that's the structure. Table name, add the data. Yes, the data is an item, and here is the list of attributes and attribute values for that item. So that was very, very clear. So you can see why this kind of structure is so good for loading data into DynamoDB. It's just so easy to break down. So the command that's actually going to load this data into DynamoDB is, again, an AWS CLI command that says AWS DynamoDB, and the action is going to batch write items. Okay, so batch write items is used to load or insert multiple items at the same time instead of doing it one by one. So let's copy the code, okay, and let us paste it here and let it run. Look at that. So it's running now, and we're even getting an output that says unprocessed items. What does unprocessed items mean? So after every time it runs this command, unprocessed items basically tells us that unprocessed items is a list of all the items that didn't get loaded into the data. It kind of like got left behind or got dropped off, maybe because there was an error in the way that it's formatted. But in our case, we have no unprocessed items. See how it's a list with nothing inside? That's great news. It means there were no errors when we were trying to load the data. Perfect. Awesome. And this is some helpful tips if you run into an error while trying to load the data. As you can see here, we don't have any errors, but if you do, this piece has a few instructions on how you can go about it and resolve those errors. And if you were also wondering, there were a few commands that we haven't discussed yet. So for example, we have talked about batch write items. It's to upload a lot of items at once. But here, the rest of this command is saying, yeah, we're going to upload a lot of items at once. Those items, request those items, get those items from a file inside this CloudShell environment, and that file is called common.json. And that file is called post.json. That file is called forum.json, so on and so forth. So let's take a screenshot of the command and some of the results. Okay, and then we can move on. Nice. So I'm going to upload my screenshot. And what was the command that we ran? I ran a CLI command in AWS CloudShell that, all right, so I ran a CLI command in AWS CloudShell. What does a CLI command do? What does it do? This command will load multiple pieces of data, i.e. load multiple items into DynamoDB tables, into the DynamoDB tables I set up in the previous step. Cool. This AWS CLI command is structured as AWS DynamoDB batch write item, request items, file / so on and so forth. 0 characters left. That's okay. Done. Okay, so now that we have sent through a command that successfully loaded a lot of data, we have no unprocessed items left, what should you expect? If you were to refresh your page, can you now expect items to pop up here? Do you think so? Let us find out. So let us click on the content catalog table, okay? And let us refresh this and see what happens. Oh, look at that. So after we ran the command, we successfully loaded some data. Very cool. So what is this that you're seeing? Okay, it's a lot of stuff going on, isn't it? So here we are seeing a table with 6 items. All right, each item has its own attributes like authors, content type, difficulty, price, project category, so on and so forth. And then these IDs also have their own, these IDs are also their own unique numbers. Okay, so this is data that came from the file we unzipped and then we now loaded with this command. And here you can really see that there is a partition key, right, of ID. So ID will be the way that the DynamoDB can now sort through and filter through this data. If you want to see the original JSON file for this, look at that. We were looking at content catalog, right? And look at that. There's in this JSON file, you have a number, which is 1, a title, a URL, an author, Natasha. All right, so let's look at the thing with the item ID 1. Look at that, you have authors, Natasha, you have content type project, easy peasy difficulty, so on and so forth. So it's exactly what you defined in the JSON file, now shown as an item in a table. So let's take a screenshot of this table. And let's put that screenshot through. Nice. So what do you think this table is displaying? You don't need to be worried about putting in the right answer because what you write here won't end up in the documentation. Okay, it's really just for your own learning. This table is showing us 6 items, each with unique IDs. What else do you see? Pause this video now and give yourself a chance. Give yourself the chance to write this answer by yourself before we continue. So pause it now. And in this case, for myself, I'm gonna say content type is quite interesting, right? There's project and there's video as content types. Both video and project content is stored in this table. And there are also other attributes like difficulty, price, URLs, etc. Cool. So take a look at the content type column. Some items are projects, some items are videos. This means this table stores the entire collection of content, which includes our step-by-step project guides called projects. Okay, and then there's also different kinds of content, which is like our videos. So we're kind of like using a database to store all of the information about our content. Let's click into a project. Let us click into the project that has an ID of 1. So click into that, and look at that. You get to see all of the attributes for that item in one place. So all of the attributes for the item with ID 1 is here now. Content type, project, difficulty, easy peasy, price, 0, and so on and so forth. So let's take a screenshot of this very handy view. And let's add that screenshot to our project guide. All right, let's send that through. All right, so what attributes do you see in this project item? I checked a content catalog item, which had the following attributes. It has, you can see it right here. It has ID, authors, content type. What else does it have? Difficulty, price. Wow. Project category. Published, title, and URL. Lots of attributes here. So we're going to click on New Attribute, and we're going to select a string, which means a piece of text. In this, we're going to say the name is going to be Students Complete, and the value is going to be Nico. Okay, so when you're done, click Save and Close. Done. So what we've just done is we've just updated a piece of an item by adding a new attribute to it. So scroll through this attribute organizer, or this header, and do you see how now for the item with ID 1, there is a Students Complete attribute now called Nico. The attribute we've added is here right away. Awesome. Does that mean Students Complete is now an attribute for all of the other items? Does that mean there's now Students Complete attribute for 2, for 3, 201, 202, 203? Like, can we now fill in this field for 2? Let's find out. Let's try open a video item. So this time let's open the item with ID 203 at the bottom. Let us see all of the attributes here. Oh, interesting. Now we have content type, we have price, services, title, URL, video type. Where is the Students Complete attribute? It's not even here in the first place, right? And this really, we're going to answer this question, and then we're going to discuss what that means. So I checked another content catalog item, which had a different set of attributes. They were services, title, video type, etc., etc. Some of the other attributes are the same, so you don't have to list them out, and then we can click Done. Awesome. So as you can see, that Projects Complete attribute wasn't even here. This is the reason why DynamoDB is just known for its flexibility. Every single item in that DynamoDB table can have their own set of attributes, right? You can see that it's its own set of attributes. It's different from the set of attributes from the previous item. Just because Students Complete is an attribute in that first item doesn't mean there's now a Student Complete attribute here that we can fill in. Because the items are completely flexible. They have their own set of attributes, and they don't, adding an attribute here doesn't mean you're going to add that attribute there as well. So what's the difference between this and a relational database? Why is that information important? Well, because relational databases don't have that flexibility. So it would need each row to have the same number of columns. So if you added students complete as a new column in a relational database, so not in DynamoDB, but in a relational database, every item in that database will need to have a student complete value too, even if that doesn't actually apply to them. So this has a huge impact on DynamoDB versus a relational database in terms of flexibility and speed, right? In terms of flexibility, DynamoDB has a huge advantage because now attributes can have items can have their own set of attributes, and this is great for situations where items in a table could just look very different from each other. In our case, we have projects and we have videos. They're like two different types of items. They're going to have two different sets of attributes. It's going to be hard for me to have a video type attribute for a project. And just like that, students complete wouldn't really make sense for a video. And in this case, in the real world, there's like e-commerce sites, and a shopping cart would probably need to store a lot of different kinds of products, each with their own attributes, and they all need to live in the same place. So a shopping cart, so a DynamoDB table, which stores things using key value pairs, which means different sets of items and attributes, makes a lot of sense. Now, this is the reason why speed is such an advantage for DynamoDB as well. DynamoDB tables can use partition keys to split up a table and then quickly find the item that they're looking for. For example, here, if you had a partition key where you can easily split up your data into all videos here and all projects here, it is a lot faster for DynamoDB to now break down all of the data in that table and quickly find the one that it actually needs. This is an advantage over like relational databases because relational databases would need to scan through the entire table to find the piece of data that they're looking for, and that can really slow down your performance too. With all of this talking about all the advantages of DynamoDB over a relational database, it's a good idea probably for us to now think about, then what's the benefit of the other thing? What's the benefit of having a relational database? When will someone pick that? Honestly, the advantage of having a relational database, two things. One is all of the querying power that you get. Relational databases use SQL, which makes handling complex queries just a lot more straightforward. SQL is a query language that we learned earlier in this series, and that level of querying is actually very, very unique to SQL. Like SQL is just really powerful, and you can't use SQL on DynamoDB. The strictness of a relational database schema is also a great advantage because what if you have a use case that simply needs all the data to be very consistent with each other? It's almost like you need that to happen for your data to be considered good quality. In these kinds of scenarios, you would use a relational database because it really needs every single row to have the same number of columns, which really keeps your data very consistent row after row. All right, so take a screenshot of your attributes panel for this one. Cool. Nice. And then let's answer a question. How is DynamoDB more flexible than relational databases? A benefit of DynamoDB over relational databases is flexibility because items can have their own set of attributes. Compared to relational databases, because items can have their own set of attributes. This is great for scenarios where a table will hold data. A table has different kinds of data, and some attributes don't apply to all data in that table. How does DynamoDB perform faster than relational databases? We talked about speed. So how is it that DynamoDB has greater speed? Another benefit over relational databases is speed because DynamoDB can find items quickly using partition keys. This is faster than relational databases, which need to scan entire tables to find specific pieces of data. And let's be clear here. What's really happening is the benefit over relational database is speed, because DynamoDB can find items quickly using partition keys. Because DynamoDB can quickly partition its data. It's kind of like splitting up the data to narrow down. DynamoDB can quickly partition data to narrow down a search using partition keys. Perfect. Let's click done. So what that really means is, you know how a relational database, we need to scan through an entire table in order to find a piece of data. DynamoDB can use the partition keys to quickly divide up that big table into smaller chunks, and then search within that smaller chunk, search within another smaller chunk, search. It can narrow down the search really, really quickly, because partition keys help to cut up your data into smaller bits. And DynamoDB would know, oh, how do I need to go to this smaller bit, because this smaller chunk of data, or the smaller partition of data, has the partition key matching what I'm searching for. Nice work! So you've just learned how to create a DynamoDB table. You've also learned how to load data. Thanks for getting the ball rolling and creating this database. You're off to a rocking start as Nextworks data engineer. Next up, we'll be running queries on this database to extract some juicy insights. That's in the next project. I hope you enjoy that one too. In the meantime, let's delete our resources and wrap up the project for today. Now, you can try to delete all of the resources by yourself, and you can definitely do that, because this project is extremely simple and you're really only using one database or one service where you really need to delete the data. So in our case, you can delete your DynamoDB tables just like this, click this, and click delete, and done. Okay, so this is totally possible, but what we can do instead is to use CLI commands to delete your resources. Okay, so back in here, what if you can just use these commands to say delete table, so on and so forth. Okay, let's run those now. Oh, so as I ran this first one, as you can see, there's this view, and if you see that colon at the end with that little rectangle, do you see that colon and rectangle? Just press Q. Okay, and let me just try running those commands one more time. Cool. All right, and it seems like I might need to run Q every single time I do this, or you can press enter. Maybe we need to press enter. Or no, we do need the colon, we do need to press Q. So again, just run that command for the next one, and then press Q when this colon comes up. All right, and then you can run this for the next one. Press Q, run it again for the next one, and press Q. Nice. So that was basically how you could use CLI to delete your resources, delete your tables. Now, I know running that one by one and pressing Q was not very efficient, and I was actually surprised that we needed to press Q as well. That was my first time actually seeing that Q situation pop up. So if you see that happen to you, just remember to press Q and you'll be okay. But I'm still wondering why I needed to press Q in that one. Anyway, back in the tables page for your DynamoDB service, if you were to click refresh, the tables are all gone. You've deleted them with CLI. Great work. Now that is another service done today. You should be so proud of yourself. We don't need to delete this CloudShell environment because this CloudShell environment doesn't cost anything to run, so you'll be all good. But in the meantime, please make sure to answer these questions. What is Amazon DynamoDB? Why is it useful? Is a non-relational database service with AWS that organizes data using key value pairs. Whoop. How did you use Amazon DynamoDB in today's project? In today's project, we use DynamoDB to, what do? We use DynamoDB to create 5 tables. We used CloudShell and CLI to load data into our tables quickly. And is there anything else we did? We also compared DynamoDB to a relational database by understanding how items and attributes work. Attributes work. What is one thing you didn't expect in this project? One thing I didn't expect in this project was that we could perform a lot of actions using AWS CLI instead of the console, e.g. creating tables, loading data, deleting tables. They could all be done. We could even read the file that we loaded in. That was all really handy. Cool. How much time did this project take you? This project took me 60 minutes, including documentation and understanding time. I actually don't have a clock with me right now, so I don't know the true time of this this project demo today, but let's just say it took us 60 minutes. Should be close to that. I'd be laughing if it wasn't when I watched a playback for this. All right, so now that we've answered all the questions, we can scroll all the way to the bottom and you can see that you have completed this project. You've done all of the parts of this architecture diagram, right? So you should be very proud of yourself. We've gone from data to using AWS CloudShell to load that data into DynamoDB and into those tables that you've already created. So good. So you've created the DynamoDB table from scratch. You did that for the very first table, Next Week Students. And then for the rest, we're like, you know what? We can make it so much faster by using the CLI. So we use the CLI to create tables very quickly. And then we use CLI to load that data into those tables. And then we also used the console to edit the data. And that came with so many learnings about DynamoDB versus relational databases. Great work. And if it still says still task complete, what you could do is you could use these arrows in the side to just double check whether there's something that you haven't done yet. Whoop. I feel like we might actually be done with all of the tasks. If it says still tasks to be done, the reason for that is actually because I think there might be something that I've set up incorrectly while writing this project. So that is a very good reminder to look into this. So apologies, everyone. Let me look into this in a second. But you can absolutely still see the documentation for today by, I'm going to use a special way to view documentation where you have your URL and at the end you write document.html. All right, and look at that, beautiful work. Let me actually open this in the main tab so you can see it clearly. Look at that. So we've successfully written up our documentation and we've from all of the answers that we've written. Oh, I believe. Oh. There we go. Sorry about that. There was a bit of a glitch there with how I could navigate my document. But now that you have your document in front of you, just look at how all of the responses that you've put into all of those questions is now in front of you as documentation. What is Amazon DynamoDB? And all of these questions that we've answered together throughout this project all collated together into a document for you. So this is automatically generated when you click on that blue Mission Accomplished button. And you can easily share all of this on LinkedIn as well. When you share it on LinkedIn, what that looks like is it looks like this. Whoop, whoop. It looks like this at the very end. Let me show you. It seems like I can't press the button here. Oh, that must be a little glitch over here. What attributes do you see in this video item? I'm pretty sure we've actually answered that question, so let us just put our answer through. Sorry, team. There must have been a little hiccup with the way that I've set up this project, but this issue shouldn't be there by the time you do this project. This one's on me. But let us have a look at this LinkedIn button, which lets you actually share your project on LinkedIn. Look at this. Copy is all ready. Do you know the differences between DynamoDB and relational databases? You can follow this copy. It is extremely just LinkedIn post ready. You can just click post right away. But what we'd recommend is you can click X. All right. You can click add a document, choose a file, and then you can, put your document in here. Oh, this is someone else's documentation. So a big shout out to the student that I'm uploading this dummy documentation for. Let's just say the title will be your name. And then the project is called Load Data into DynamoDB. Okay, and once it's done, all right, make sure you're going to choose, double click on this network text here. Make sure that you are actually tagging us like this. And then you can click post. Off you go. And with that, we are all done with today's project. Look at that. You have done so much. You have created some awesome things. And are you ready to supercharge it and also put through some queries, get some insights into your database and into your tables for the next project? I hope you are. We'll see you in the next one. I'm sure we'll catch up again very soon. All right, so that is a wrap for today. Please take care and let's stay in touch. Ask all of your questions in the community in the meantime. Apologies that we're ending on quite a funny looking note, but I guess this looks better as an ending screen. I'll see you in the next one, everyone. Bye.